You have probably gazed at the sky on a clear night and wonder whether there are aliens or parallel universes out there. With the advent of space explorations, the notion of living on Mars has already been entertained by some people just in case Earth ceases to be a habitable planet in the future. Welcome back to Learn New Things today. In this video, you will learn how the Greeks knew that the Earth is spherical. The Mesopotamians, as accounted in their mythology around 6th century BC, described Earth as a flat disk floating in the ocean and bounded by a spherical sky. This idea has prevailed for hundreds of years until a new view was presented. As the quest for knowledge continues and civilization prospers, several models of the universe were presented, and it is categorized as a geocentric model, or Earth-centered, and heliocentric model, or Sun-centered. In the geocentric model, the Earth was at the center, and the rest of the planets and heavenly bodies revolved around it. While in the heliocentric model, the Sun was at the center, and the rest of the heavenly bodies, including the Earth, moved around it. In all of the geocentric models of the universe, the Earth and other heavenly bodies were assumed to be spheres. They were convinced that the shape of the Earth was not flat. Instead, it was spherical. This idea was already entertained by Pythagoras and Plato. However, they do not have concrete evidence to support their claim. Until Aristotle around 320 BC, a student of Plato presented his arguments that established the claim during their time. Aristotle argued that, first, the sphere is perfectly solid and the heavens are a region of perfection. Second, the Earth's component pieces, falling naturally towards the center, would press into a round form. Third, in an eclipse of the moon, the Earth's shadow is always circular. Thus, if Earth is a flat disk, it would cast an oval shadow. And lastly, even in short travels northwards, the pole star is higher in the sky. Another phenomenon considered by Greeks in their claim of Earth's spherical shape was navigation. They observed that when ship sails away, it seems that it gradually disappears behind the horizon. However, if it is not a sphere, then why measure its circumference? One of the astronomical events that fascinated early civilization was the eclipse, and the recorded information about eclipses was used by Eratosthenes about 235 BC to approximate the circumference of the Earth. This was another proof presented about the spherical shape of the Earth. As you know, an eclipse is a shadow formation. This happens when the path of light rays is blocked by an object. And how does he do it? While working as a librarian at the University of Alexandria in Egypt, he came across information that during summer solstice, especially at noontime, sunlight shines directly down a deep well in Seyene, a city south of Alexandria, and reflected up again, and no shadow is cast by any object on a noontime. But in Alexandria at the same time, date and time, a vertical pillar and other structure cast a shadow. And so, Eratosthenes measured the shadow cast by a vertical pillar in Alexandria, and he found out that it is 1/8 of the height of the pillar. This is roughly equivalent to a 7.2 degrees angle between the sun's rays and the vertical pillar, while in Seyene it is 0 degrees. Based on his calculation, 7.2 degrees is equivalent to 1/50 of a circle. Thus, it follows that the distance between Alexandria and Seyene must be 1/50 the circumference of the Earth, or the Earth's circumference is 50 times the distance between the two cities. Since these two cities are frequently traveled, the distance was measured to be 5,000 stadia or 800 kilometers. So the Earth's circumference is 50 times 5,000 stadia, and it is equal to 250,000 stadia. Take a look at the diagram and it will tell you that when the rays shine directly above Seyene, it is not directly overhead at Alexandria, which is around 800 kilometers north. The pillar in Alexandria cast a shadow, while the water in the deep well at Seyene directly reflected the sunlight. Are you convinced that indeed the Earth is spherical? Well, to learn new things today, drop your comments, like, and share this video.